Okay, let's dive right in. Today, we're going to break down a pretty radical proposal that's designed to solve a massive problem in how we train engineers. It's all about tearing down old walls and building something completely new from the ground up. Wow, a crisis of relevance. That's not a small claim, is it? It basically says that what's happening in the classroom is dangerously out of sync with what's needed in the real world. So this whole initiative isn't just a minor adjustment, it's a full-on response to that crisis. All right, so let's start with the core problem. What exactly is this outdated model? And why is it failing not just the students, but the industries that are desperate to hire them? Well, it all boils down to one thing: academic silos. Okay, so picture this. Imagine you're training a Formula One pit crew, but you train each member in a completely separate garage. The tire changers never talk to the refuelers, and the data analysts are in a building across town. It sounds nuts, right? Well, that's pretty much how traditional engineering education has worked for decades. Students get really, really good at one thing, but they're totally cut off from the other experts they'll be working with every single day of their careers. And this slide, man, this just lays out the disconnect perfectly. The old way creates graduates with a ton of book smarts, but they're just not ready to work in a team. But what does industry need? They need people who can do both. They need that deep expertise, sure, but they also need it to plug seamlessly into a collaborative team. The real kicker is that the world's biggest challenges aren't just chemical engineering problems anymore, or just IT problems. They're a messy mix of everything, and they require everyone working together from the get-go. So you have this huge gap. How do you bridge it? You can't just throw another group project in the syllabus and call it a day. No, you have to build an entirely new ecosystem. And that, right there, is where the virtual production solution comes in. This is the game changer. Think of the VP platform like a super advanced flight simulator, but instead of a 747, it's an entire industrial plant. It's a shared digital world where, and this is the key part, students literally can't succeed on their own. They're forced to communicate, to compromise, to integrate their different skills to make the whole system run. Just like in a real company. And this isn't some simple little program. I mean, just look at how deep this simulation goes. It's built from 5 interconnected blocks. You've got the core industrial process itself, then you have the control systems that actually run it. On top of that, there's a powerful engine for data analysis and machine learning. Then there are custom dashboards for different users and a security layer wrapping around the whole thing. This isn't a toy. It's a full-blown professional-grade digital twin of a real-world operation. So, you have this amazing platform. What do you do with it? Well, you make it the absolute heart of the entire curriculum. It becomes this shared sandbox for 3 brand new master's programs that are designed to work together. This is where those old silos just get completely bulldozed. So how does this actually play out in practice? Well, you've basically got 3 specialized teams on one big project. The chemical engineering students, they're the architects, designing how the virtual factory actually produces its product. The automation students, they're the system engineers, building the controls to make it all run smoothly. And the info system security students, they're the guardians, the cybersecurity pros protecting the entire digital operation. Each group has its own mission, but none of them can succeed unless the other 2 succeed. They have to work together. Okay, so what's the payoff? What kind of engineer actually graduates from a system like this? The whole point is to create what the industry is desperate for right now, a T-shaped professional. And that just means someone with deep expertise in one area, that's the vertical part of the T, but also with the broad skills to collaborate with experts in other fields, that's the horizontal bar. And all of this really boils down to one simple but incredibly powerful number: 2. Why 2? Because every single student who graduates from this program leaves with a dual specialization. They're not just a chemical engineer anymore. They're a chemical engineer who also knows front-end development. They're not just an automation specialist. They're an automation specialist who understands back-end data management. In today's job market, that's basically a superpower. And we're not talking about some minor add-on skills here. These are the heavy hitters. Every graduate learns practical data analysis, using machine learning and neural networks to make the system better. And they get legitimate web development skills. The technologists build the user interfaces, while the automation specialists manage the data behind the scenes. They can actually build stuff. They can talk the talk and walk the walk. So, this all sounds amazing on paper, right? But is it just a pipe dream? How do you actually make it all happen? Well, that's the thing. This isn't just an academic fantasy. There is a rock-solid plan to take this from the classroom and plug it directly into industry. The plan is basically a three-pronged attack. Internally, they're setting up a dedicated lab and a student club to be the hub for all this work. Externally, they're partnering with major industrial companies, using real-world data to make sure the simulation is legit. And looking to the future, they're already planning to integrate modern AI to speed up development and even turn this into a research tool for Ph.D. students. This thing is built to last, and it's built to evolve. You know, what's so brilliant about this whole model is the feedback loop it creates. It is a genuine win-win-win. The students get a massive head start on their careers. The university cements its reputation as a true innovator, and industry? Well, industry gets exactly what it's been asking for: talented people who are ready to contribute from day one, and maybe even a new piece of software to help them solve their own problems. It's just a really powerful model for engineering. And it leaves you with this final big thought. By putting a collaborative, real-world project at the absolute center of learning, maybe we could solve this crisis of relevance, not just for engineering, but for all of higher education. I mean, just think about it. What if every single degree worked like this?